Friction, resistance to sliding motion. Friction is one of the most fundamental forces in physics that affects nearly every physical interaction around us. Throughout this lesson, we'll explore how friction works, why it matters, and the mathematics that describes it. Friction is a contact force that opposes or resists the relative motion between two surfaces in contact. Whenever two objects touch each other, their surfaces interact at a microscopic level. These interactions create resistance that acts against any attempt to slide one surface across the other. Friction always acts in the direction opposite to the motion or intended motion of an object. There are two main types of friction we need to understand. Static friction prevents motion from starting. It acts on objects that are at rest and keeps them from moving when a force is applied. Kinetic friction opposes ongoing motion. Once an object is already moving, kinetic friction acts to slow it down. Both types work in opposite directions to the applied force, but they behave differently in terms of magnitude. Static friction acts when surfaces are at rest relative to each other and adjusts to match the applied force up to a maximum value. The force of static friction can vary from 0 up to a maximum limit. The relationship is expressed as F sub s is less than or equal to mu sub s times n, where F sub s is the static friction force, mu sub s is the coefficient of static friction, and n is the normal force. The inequality symbol tells us that static friction can be any value up to its maximum, depending on how hard you're trying to push the object. Kinetic friction acts when surfaces are sliding past each other and remains relatively constant during motion. Unlike static friction, kinetic friction doesn't vary with the applied force. Once motion begins, the friction force stays approximately constant. The equation is F sub k equals mu sub k times n, where F sub k is the kinetic friction force, mu sub k is the coefficient of kinetic friction, and n is the normal force. Notice this is an equality, not an inequality, because kinetic friction has a fixed value during motion. The coefficient of friction, represented by the Greek letter mu, is a dimensionless value that represents the ratio of frictional force to normal force between two surfaces. Mu has no units because it's simply a ratio of two forces. Different material combinations have different coefficients of friction. For example, rubber on concrete has a high coefficient, meaning lots of friction, while ice on ice has a very low coefficient, meaning very little friction. The coefficient tells us how grippy or slippery two surfaces are when they interact. There's a critical relationship between the two types of friction coefficients. The static coefficient, mu sub s, always has a higher value than the kinetic coefficient, mu sub k. This explains a common experience. It's harder to get an object moving than to keep it moving. Starting motion requires overcoming the higher static friction, but once sliding begins, you only need to overcome the lower kinetic friction. This is why heavy furniture is difficult to start pushing, but becomes easier to slide once it's moving. 4 key factors influence friction between surfaces. Surface texture refers to the roughness and smoothness of materials. Rougher surfaces generally produce more friction. The normal force is the force pressing surfaces together. Greater normal force means greater friction. Material types matter because different combinations of substances have different natural grip levels. Interestingly, contact area does not affect friction. A block lying flat experiences the same friction as the same block standing on edge, as long as the normal force remains constant. This might seem counterintuitive, but it's a fundamental principle of friction.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.